so we actually use this to teach children how to code. Okay. Because normally, if you of course coding, it's always difficult to give someone a rewarding feeling.
Yes, and now
because now you physically create something, you get direct satisfaction by learning how to code.
Ja, zoals het hoort. Over een BSD moet je niet vragen hoe het moet.
Dan moet ik nog even op een...
Camera en stream staan aan, dus...
Disco systeem die hebben. Iedereen gaat een koptelefoon op met ja, dat ga ik door.
Is this bring laptop workshop?
If you want, you can also go listen and then do the laptop.
Does it have to be a good laptop? Because my laptop is very old and very shit. It's a cheap one. Oh well.
Heb je de slides er ergens staan?
Ja, dat zou zo op de wiki zo gaan.
Dat heb je wel. Als ik moet het gewoon open doen en dan het gordijn ervoor, kunnen mensen er makkelijk in.
Maar wat denk je voor denken? Dan kunnen mensen er nog wel in tenminste. Of download. Moment, ik zeker uitvoeren. Een Windows toetsen installeren duurt ook 15 seconden. Dus mooi makkelijk gedaan. Waiting for one more person. I think she's getting her laptop.
Ik heb ooit een heel simpel watje gehad. Een van het Any-Key project. Maar dat was Duits volgens mij.
Wat heb je?
Een heel klein PCB'tje.
Ja, dat
heet
is
het Any-Key bordje volgens mij.
Ah ja, dat is
Dat is niet van jou toch?
ik heet officieel eigenlijk niet Any-Key, maar de Any-Key. Nuances. Nuances. Ga ik zelf ook verkeerd op zien. User Any-Key. Okay, let me start. Welcome to this workshop. It's OpenSCAD. Making something, physical things, or just virtually, by coding. If anyone, I don't know, anyone owns here a 3D printer? No 3D printers? Want to buy. So I've always been amazed myself about how many people nowadays do have 3D printers, but how little people that actually have 3D printers make stuff themselves to print out. I find that most people that have 3D printers just spend all their time on Thingiverse finding things that other people have designed, and that's what they print out. Which for me is quite a shocker, because I think the whole purpose of getting a 3D printer is to make your own things with. But a lot of people struggle making things in 3D. If you go to the normal graphical drawing programs, a Fusion 360, even a Tinkercad, I don't know, it's sometimes quite a hard struggle to actually start designing something. So I personally think a great alternative to making things is by using something called OpenSCAD. What is OpenSCAD? It's open source. It's available on any platform you can think of. Linux, Windows, Mac. It runs on a Raspberry Pi. So literally any kind of platform you can seriously run. On a very shitty old laptop, on anything you can run this. So that in that way it's very accessible. And it is an interactive, it's not an interactive malware that you're drawing and while you're drawing you can modify things. No, you write code, you press a button, and it generates the 3D model for you. That's the basic concept of what OpenSCAD does. So just to give you a simple example, so there are some basic shapes in life, right? You have a cube, you have a sphere, you have a cylinder. There are some more complex shapes as well. We'll come maybe later to. But if I, for instance, want to have a cube, I literally just give the command cube with its width, depth, and height, and it draws me a cube of those dimensions. And these numbers just represent whatever you want them to represent. In my case, I use millimeters because my printer is set to millimeters. So in this case, it will draw a cube of 1 centimeter by 1 centimeter by 1 centimeter. Very, very simple. The syntax, by the way, if you have ever developed code, is very much like a C language. So at the end of any commands, you have to do the semicolon. That's the separation to go to the next command. And it doesn't matter if you write 5 commands on one line or 1 command per line, or even split a command up over multiple lines. The semicolon is the differentiator between going from one command to the other command. So besides the cube shape, there are some other shapes. And when you start looking around you in life, after you've done this, you start recognizing all these basic shapes and everything and how you can very easily then recreate it. But one other very common basic shape is a cylinder. That's something round. And it has a radius, that's what the R stands for. So that's from the middle point to the outside. Do you all know the difference between radius and diameter?
Yes.
I won't go math lessons, you quickly learn as you make a lot of mistakes. Because you can also specify D is. So diameter is from all the way to the left to the right. The radius is from the middle to the outside. So this will create a cylinder of 1 centimeter thick and 1 centimeter height, round. That cylinder can actually also have two radiuses. So if you, let me just give you an example. I have my environment here. So I have the cylinder, and I specify a radius of 10 and a height, I don't know, of 10. If I say render, it renders it, as you can see. I have my So I have my cylinder here. If I, for instance, specify 2 radiuses, so I can specify radius 1, and I can specify radius 2, something like this, I get a cone. So you can be flexible with this shape. Now, so there's some basic shapes: a cube, a cylinder, and I guess that the other basic shape is a sphere. A sphere is a ball. So if you do a sphere with a radius of 10, you get a ball. Very simple. Now, actually, if you look around you, everything pretty much you see, you can make out of those 3 shapes. Especially because in this language, the key thing what you can do is you can do operations on 2 objects at the same time. So one of the operations that you can do is a difference. And what does the difference command do? Very simple. It draws whatever you first say completely, and everything else that you afterwards specify, it subtracts it from it. So again, this is C syntax, so you have a difference, which is a function, so that's why you have the brackets. And then you have the curly bracket opening and curly bracket closing, which defines whatever is your difference part. And then I said, the first thing you draw within that part, it draws, so I draw a cube, and then I also draw a cylinder, but actually that is then being removed from that cube. And so this way I end up having a square with a hole in it. Very, very simple.
You also do exclusive OR with objects?
So yes, I will give you later on a cheat sheet. There are some more complex ones, but the most commonly ones you will use is a difference, which subtracts. You have something called intersection. So that's only where the 2 objects meet. So only wherever there's overlap between all the objects, that is what stays. You have a union, which just combines it as one module, that doesn't really change the shape. But the one that I love a lot is the whole command, and I think I'll show you later an example of it. So, oh, there we go. So this is what you did. So let me give you an example. So one command that you will learn is the moment you draw anything in OpenSCAD, by definition it draws it on 0.0.0 coordinates. So at the dead center in the middle of your grid. So with the command translate, you can decide that you want to place it somewhere else. So what is key here, just from a syntax perspective, some people at the beginning are a little bit confused always here. The translate command, you should not end with a semicolon, because you end that command. So the translate without semicolon will then apply to whatever you specify next on it. And you have that with other commands as well, like if you have a rotate command or a coloring command, make sure that they're part of the command so that that's will execute. So here I am drawing on 0.0.0 on the center point a cylinder. I draw 3 centimeters to the right a cylinder, and I draw 3 centimeters up a cylinder. So I now have these 3 cylinders placed, very simply. Then there is this command called a hole command. And what a hole command does is it takes whatever object you have placed, draws a parameter around it, and makes that into an object. And this can be complex. This is actually a hole of a 2D object, right? I have the cylinders at the same height. If I, for instance, have a cylinder floating in the middle of the top, I literally get a kind of pyramid kind of shape. So wherever you place things, it will make the hole, the shell around it completely to do. I personally think this is a very powerful command. You can do lots and lots of things with it. You very easily just place some dots and then you put a hole around it and you've got your much more complex shape if you want to. This also is very commonly used is when you start 3D printing. You typically don't want very square corners. You typically want round corners, a lot of things from a printing perspective. So instead of drawing a cube, I typically always draw 4 cylinders with a radius so that I have a cube with rounded corners on it. So it's very simple to do. And as I said, this is a programming language, and because it is a programming language, I can start really using all the kinds of programming elements, making modules, making my own functions, to simplify my own life. Now when you draw something, so here I said I'm drawing the first bit you saw with the hole, I draw the 3 cylinders. Around that I throw a difference. So with the difference, it draws the first thing first, so it draws anything that's within the hole command, it treats as one object. Right? So that's why it draws that. And then I literally remove, again, identically the same 3 cylinders with just a smaller diameter, so I get that shape with 3 holes in it for me to play with. So very simple. Now, as I said, it is a programming language. And if you've never programmed before in your life, this is a great method to learn programming. But of course, one of the key things about programming is to be able to reuse your code, right? And make it very simple for you to do as much as possible. So what I can do is that shape that I just had, I can create modules. And this is my own command that I just create on the fly. So I can make a module to make a triangle with its width, right? I make it with a parameter. And what that does is it draws it places those 3 cylinders with a hole around it. Based on the width command, the distance between it. So this is how I can specify very easily then what the size of my triangle is. And in my main program, I literally now just have one line of code. I have drawn me a triangle with whatever triangle width that I need. So this really allows you to extremely simplify your code and reuse every single time if you have a certain object that you want to draw, just maybe with different dimensions and those kinds of things. The same thing for the holes. I have a module for my holes with the diameter of the holes, and we will then just use the difference command again to take those holes out. And I think this is always best practice, in the beginning of your program you specify your key variables. And this is especially if you start 3D printing your objects, very important. Because when you start 3D printing, every 3D printer has a different tolerance. So even though I measure something should be 4 millimeters, and I print it out, I don't know, it might be 3.95 or 4. And sometimes just that 0.5 millimeter makes it not fit or makes it fit. And that's really where OpenSCAD becomes extremely easy. If you work with Fusion and all that kind of thing, especially like a Tinkercad, later on modifying everything is just sometimes a pain in the ass. Here, you modify your parameter, re-render, and you're done. So it's very simple to iterate and adjust your model if you work well with parameters. Now to learn from examples, I don't know if you know Thingiverse, but Thingiverse, number one website pretty much where everybody downloads shit from. On Thingiverse, if you actually go and explore, there's something called customizable things. That means that all these objects that you see here, you can customize. And why can you customize them? Because every single object you see here is written in OpenSCAD. It is written using this language. What that also means is that you can therefore steal from it. So if I find something that like, oh yeah, how on earth did they make this particular shape here? You can open up in Customizer, or you can just download the file, whatever you want. And
dialect noises.
yeah, there you go. Fast, isn't it?
Someone meticulously signing in with a goose feather.
Thingiverse is notoriously slow.
Yeah.
So logging is, normal, for some reason their authentication, I don't know where it goes back to Autodesk, so I don't know, it's alternatively.
Dus can you just download these OpenSCAD files?
Yeah, so if I don't open up the Thingiverse, you can just go to the files here, and here's the OpenSCAD file as well. So
Nice.
you can just agree,
Rumored to be maintained by one single person at this point.
Yeah, Saturday.
They changed it.
Oh, it's really.
Just freaking slow. So yeah, there's just OpenSCAD file here. OpenSCAD, there we go. So my font is a bit big, so it might be a bit challenging to read. But here you can see also that this person very clearly in the beginning of his code has assigned the main parameters. Oh, I think it's random. Oh, that's why. It's making my laptop doesn't. So, one thing on that. So, when you start designing, you will very often render, right? You can decide in what quality you want to render. And this is something that I think you need to be aware of. So, in the top of the program, you see the string fn function standing there. That defines the quality of how high you want to render your model. While you are designing, you probably want to have that extremely low, like at 10 or something like that. And then because every time you can very quickly render, it might not be super pretty, but it will work. And then when you want to 3D print it, then you want to crank this up, render it one more time, and then you can save that to an STL file, which you then send to your printer. So here is that thing, whatever it is. The spring, a ring, it's a spring. So as you can see, they clearly have defined at the beginning the variables. They made some nice comments about it, so you know how to what the other of these things do. And then you can just find the code, so you can actually have a look at how they made it, make modifications to it, and all that kind of stuff. So Thingiverse.com is a great way to still learn from others. And I can tell you, a very common type of objects, there are definitely OpenSCAD libraries for. So if you need a gear, don't go think about making your own gear. Trust me, there are some super libraries for OpenSCAD for gear making. You just specify literally, I want a T12 or whatever name or model type of gear with so many spruces and all that. Hit the button and you get your gear. And then you can still make modifications to it.
So can you include these libraries?
Yeah, it's a programming language. So you can download additional libraries, have an include in your program, and you can leverage them. Same thing for text. There is some basic text support in OpenSCAD if you want to put letters up. But there are some really cool libraries to make really pretty 3D kind of shaped text and those kinds of things as well. So if you start searching on OpenSCAD modules, you find thousands of libraries for OpenSCAD on anything you want to do. And Because that Thingiverse already is a great source. And if you want to make a Raspberry Pi case or an Arduino case or something like that, but you want it to be different, just find the basic one that already has the base of what you want, and then you just go and change it in whatever your specifications are or something like that. So Thingiverse is a great place to find it. You find some really nice examples there. So this is, for instance, a combination lock. And they make this, of course, in OpenSCAD, because then through OpenSCAD you can define what combination should be opening the lock. Right? So it's not a fixed object. You can choose in your program what the number should be to open up the lock and how it works. So, and the Thingiverse has a GUI in front of your OpenSCAD file, so it reads out the first parameters that you define in your program, and it presents that into a nice simple menu. But you can just download this file and have it in OpenSCAD, which I think works much easier. So there's a few source button there that would just show you the source code, and then you can just copy and paste it into OpenSCAD or download the file, and then you have it. Another example, if you need a key, someone made a complete OpenSCAD program to generate keys based on a picture, but even better, I think that's that one, the quickset. If you have a quickset key, which is especially the US commonly typed key, you just need to know the number of the key, which is written on the key. You type it in your OpenSCAD, it generates the key for you, you can print it out and you have a spare key. You don't need to scan the key, no nothing, you're done. And it works, I've tested it.
You have to scan the lock, man.
Sorry?
You scan the lock, so you don't have to.
Unlocks where that is possible.
So you find, I mean, from artistic stuff to very practical stuff and anything in between you'll find on Thingiverse designed in OpenSCAD. And actually, on those two extremes you find a lot of OpenSCAD stuff. Maybe more traditional things people design in a Fusion or in the more classical 3D design projects. But you all must have seen like those insane faces, right, that people 3D print with very organic shapes in it. Trust me, you cannot make that into a standard 3D design program. While in OpenSCAD, this is just a loop with some sinus or something like that, 5 lines of code, and you have the most complex face or pot or a drinking bottle, whatever you want. So, because it is a programming language, there are some things that you can do in OpenSCAD you cannot do with any other design method or something like that, because it is highly programmable to work with. So, for today, I would like you to, of course, see if you can design something. And I actually sometimes give this programming sketch to children, and children like to make spinners. So they typically design spinners, but I think you're all probably too old to make spinners. If not, feel free to still make a spinner. A spinner is nice because a spinner is super fast to print. So we can really do a workshop with children where we teach them in 1 hour to do OpenSCAD, and in literally 30 minutes we print out their spinner. So they have very quick results physically in their hand. And I can tell you, if you've never done this before, go make something. I will print it out for you this weekend. And so you literally, what you've made on your screen, a few hours later, you can have in your hands. It's a very magical feeling, I think, to do. Now we of course have the camp badge. I already started making some basic shell casing to put it in. So you can try to see if you can make a case for your badge, which again should not be too big of a print if you want to. Make sure of course that the back end is open as well, so you can have components on the badge on both sides. It's 5 by 5 the badge. The radius in the corners is 5 millimeters. And the holes are both 5 millimeters from the 2 corners that you have in there. So it's a very basic design to make. If you want to make something else, absolutely feel free. I have, instead of before you directly go make what you want to make, a simple exercise for you here, just to learn how to make some basic shapes, to do distractions, to make the whole commands, so you can run through this if you want. And I have a cheat sheet with the basic commands on it that you need for most. On OpenSCAD.com there is a bigger cheat sheet, which has literally all the commands, but then you might not see the 3 and the 4s because of the overwhelming stuff. So maybe this is a little bit easier. If you don't want to sit here, you can feel free to go back, and if you need any help, just yell at me and I'll come help you if you have an issue with making it. In the end, if you did make something and you really want to get that gratification of having it physically in your hand, on the wiki I put my email on there in the agenda, in the program item on eth0.nl. So send me whatever you've made, and I will print it out for you. In case you want to know how that works, So in OpenSCAD, when you have made your model, all you need to do here is turn the resolution up, and I render it. So one thing I forgot to say, there's two methods of rendering in OpenSCAD. There is F5 and there is F6. So on a Mac it's function F5, function F6, on a PC it's F5 or F6. F5 renders extremely fast, but not accurate. So for printing you always need to hit the F6 button, and then it will take that resolution into account. When you have done that, you can also just send me the OpenSCAD file and I will render it for you. You can just export it to an STR file. This is the standard file that pretty much everyone uses, which is a standard open. So you can also open it up then in Mesh Mixer, in any other 3D program you can open up it as an actual solid 3D file. And then if you have a 3D printer, you just go to your slicing software, you open up that STL file, you slice it in the way how you want to print it. In the 3D software, in the 3D printing software, I define how I print it. Right? How hollow do I print it, how thick are the walls with plastic. You don't design it in your model, you just make a solid model. And then I'll print it out for you. So if you want to see how that works, if you want to slice it yourself, you're more than happy to do so. And send it to me. But just go make something. From a simple badge with your name on it to a keychain. Don't make something too big if you want to have it printed this weekend. Make it relatively small, then I should be able to cope most of your prints today. I'll leave the printer run all night, so I should be able to print quite a lot at the same time. So, any questions? Yes.
Is it possible to import some Bezier curve from Inkscape or something like that?
Yeah. So as I said, you can go quite complex. So OpenSCAD supports 2D drawing and 3D drawing. So if you or you can manually draw by 2D, by the just specifying points, and then like any other normal program, you can extrude from it, making it a 3D shape. You can do that also based on, for instance, on a DXF file. So if you have something in a Coral Draw or something else drawn as vectors, as a 2D shape, like a logo or something typically used, make sure you can save it as a DXF file, which most programs can do. And I think maybe it supports also SVG, I'm not sure. But DXF for sure. Then you can upload it, you can load it in OpenSCAD, tell it how much it should extrude, and then you have a 3D file. One other command, if you want to do it more manually, not draw it first somewhere else, there is a command in OpenSCAD to literally just specify points in 3D space, and based on all those points, it will make you a shape. And so you can, in theory, make any shape you want. Because the more points you specify, but it's more difficult to get your mindset around it. So have a look at it's on the cheat sheet. That's the only other shape that you will find that's default what people use, but it's more complex in the beginning. But if you look at everything, right, it is a cylinder with a top cylinder with two different radiuses. Everything you can vary. This is a cube with rounded corners, so this is cylinders. There's a rotate command, right? So in this case here, I would rotate my cylinders horizontally, put a hole around it, and I would literally have drawn that box. So when you start looking at everything, most things you can very easily make from a cylinder, a cube, and a sphere. For instance, if you want to make a cube all the way with rounded corners, you just place 8 spheres, right? 4 spheres on the top and 4 spheres on at the bottom and the top. Make a hole, and you have a cube with fully rounded corners, right? Because that's what the spheres will do for you. You get it? If you put the 4 so you can make really quite pretty shapes with just these basic shapes.
If you have a C and you represent the C as point cloud, or you import a point cloud from a 3D scanner, can you also import that to OpenSCAD?
Yes. I'm not sure because if you scan something in 3D, typically a point cloud will be in the tens and tens of thousands. Yes. So I'm not sure how OpenSCAD is like that.
Yes. Yeah.
I think that typically you would end up using more the normal mesh mixers, ZBrushes, and those kinds of things of the world. And this is designed more like products and functional things. This is definitely not something to modify, sculpt on an existing object. Right? That's not something I think you want to do with this. Maybe possible, I don't know. But have a go. I'll have the papers here. it's good with the laptops here, so I guess we can just go back and go to your normal desk and make it. If you have questions, just hello, yellow, I'll come help you if you get stuck. If you don't know how to make a particular shape or something, I can quickly, quite typically make a lot of things in a few lines of code. And then just whatever you make, send it to me. Just make sure before you send it, you one time read over your code that you did not make mistakes with diameters and radiuses and that kind of stuff. Because I will print out whatever you send me. I don't know if it's logical or not. So if you think you got it right, you learn. I typically have to print things 5 times before I get it right. So, but you get the hang of it. So have a go at it. I leave them here. You can take them on your way out. I'll help 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll put the documents on the wiki as well. I need to see if I can get you guys a printout as well. Do we have a printout?
Again, mine.
Nice. If people maybe later on sit next to each other, then they can.
If you have an example,
Yeah, I'll put it on the. I will put it on the wiki now then.
if I look at the thingy first and I want to pick an example to work from, which file extension should I use?
So the OpenSCAD. So you find typically on Thingiverse both the rendered version and the source code.
Yeah.
So it's the SCAD .SCAD file at the end.
It doesn't have that one.
Then it's not a customizable item.
It has set F3D, yes.
So not every object on Thingiverse is customizable, right? You have to search specifically for customizable items. And items is the design file is not for SCAD now, but this is not a customizable item. Because if you scroll up, there's no customizable. So if you want to search, make sure you explore, or you can also search and then on the left you can select only customizable things. So if you want to update or something like that, then you search. Dat is denk ik dat je van de zag net ook van Nee, dat is gewoon hier het gaan.
Maar de ene waarde hierin is...
Ja, dan is het gewoon dus een gelijkzijdig natuurlijk. Die waarde is gespecificeerd. Dan kan je dus voor iedere computer. En als je dan die waarde dan is het ongeveer dit weg. Dus je hebt nu gewoon één waarde, maar als je een uitgeefcube maakt, dan specificeer je dus tussen de regels, hoge regels. Ja.
Oké,
Ik zal wel kijken of je echt een muisje. Het werkt echt met scrollen, werkt het echt. rand en naar dus aan de onderkant van die rand maakt het net weer wat minder. Dus je dus daar een snap hebt van in. Vanuit 3D printgedachten moet je dus wel een paar differences eruit halen, zodat het plastic makkelijker kan bewegen. Dus als jij een ronding maakt, of een vierkant maakt, dus fitpress over iets heen wil doen, en dat is volledig solide, dan breek je plastic af. Dus wat je wil doen is, je wil wel die skirt maken eigenlijk. Dus je begint gewoon, je tekent op zijn kop, je tekent een vierkant cube gewoon eerst. Dan maak je een cube met een cube eruit gehaald als de rand. Daarbovenop maak je nog een keer, of een cube, of daar kan je ook een cilinder voor gebruiken, zodat die een beetje rond is. Maar die is dan weer wat dikker, zodat die dus over iets heen kan klikken. Maar wat je dan dus wil doen, is minimaal op de 4 middenpunten weer een extrude maken van die wand, zodat dat plastic wat meer heen en weer kan bewegen. Zodat je wat beter fit bent. Want als jij echt puur zo wint als solide, dan krijg je daar niet eens op.
Nee, dat was ook wel.
Je wil echt, dan krijg je al een beetje hoe groot het is, hoeveel van die inkepingjes je maakt. En dat werkt op zich goed. En dan heb je echt een goede, alleen je kan het niet meer makkelijk afhalen.
Nee, dat is niet zo.
Als je dat wil, dan moet je meer in een doosje ook soort indrukkertjes maken. Dat je dan afkomt. Ja, het makkelijk is bij het natuurlijk gaan met rondjes werken en alles goed. Ja, wat ik heel veel gebruik voor de 3D-printers, goed voor het schroeven. Op zich kan je wel best schroeven als je het vaak ook doet.
Nee.
Ik heb van die metalen inserts met schroefdraad. Dus het is een metaal dingetje met schroefdraad erin.
Ja.
De buitenkant is ook schroefdraad. En dat is zelfs goed dat het heel goed ingrijpt in plastic. Die schroef je. Dus je maakt je doosje dus waar je je schroefdraad eigenlijk moet hebben. En de diameter van dat ding is eigenlijk, dat die diameter zelf maar kleiner is voor de schroef zo. Die schroef je er gewoon in en dan gaat het weg.
Zo veel makkelijker.
Ja, maar dan kan je 100.000 keer open en dicht schroeven.
Ja, nou, dat hoeft
En dat blijft dan gewoon, zoals jij die kan ook zitten, is net die van nieuwe schroef. Als je die tolerantie goed hebt, de schroef erin zit, de muur vast. Maar als je dat 100 keer open en dicht schroeft, ja, dan ga je het plastic uitkennen. Dus ik gebruik voor iets wat belangrijk is, gebruik ik een bak vol van een M3 en M2 van die inschroefdingetjes.
Zo vaak doen ze het volledige gat als rondprint, maar gewoon als hoekig. De schroef.
Ja, nee, je print je gat nog steeds rond.
Ja, nee, maar
de diameter.
Ja, dat is wat met die insert die jij
Ja.
als je die niet wil verhouden en je wil vaak zoeken.
Het staat wel rond nog steeds, alleen nog gewoon iets kleiner dan
Ja, wat ze ook vaak doen, is de ribbels aan de binnenkant doen.
Ja, dat kan ook.
schroef daarin pakken en dat
Ja.
pakt het plastic niet zo snel.
Ja. Maar ik moet zeggen, als je, ja, dat is een beetje afstellen. Als jij een M3 wil doen en je maakt dus een gat van M2,5 of 2,8 en je print het minimaal met 3 wandwinkels ook dik, dat je die wand een beetje goed in tak houdt. Je kan zo je moeder inschroeven en dat zit echt gewoon, ja, dat is echt, maar dan ben je print afhankelijk om die een beetje te weten wat je tolerantie op je printer is. Maar dat werkt wel. Maar voor de wat zeker als je naar grotere schroeven gaat, hoe dikker je schroef, hoe meer stress je op het plastic zet, dan wil je echt die inserts gebruiken. Als jij echt een M8 schroef met force ergens in draait, dan gaat het plastic uit elkaar.
Ja, zoals jij, nou gebruik ik dan vaak van die ribbels aan de binnenkant.
Ja. Release die druk. En die kan ook echt, er is gewoon voor OpenSCAD schroefdraad leidings. Als je echt gewoon kan er maar echt schroefdraad op printen, not a problem.
Oh ja, dat is waar.
Dus,
Maar,
nee, dat kan je, het is heel simpel, want je moet je voorstellen, je hebt een opengeluid om een schroef te maken.
ja.
En dus die kan je inverse of niet inverse gebruiken. Op het moment dat je hem in een difference gooit, heb je automatisch je schroefgat.
Ja.
En hou je niet in een difference, heb je een schroef.
Ik weet alleen wel wat langer bezig met kind.
Nou, nee. Kijk, het enige wat je dus dan niet wil doen, is op 2 mm, op 0,2 mm laten. Ik wil dan niet zeggen 0,1 mm laten. Maar dat is inderdaad natuurlijk schuin hoe fijner je zet als lager maakt, hoe accurater dat eruit komt. Maar je hebt kanten, vingers zijn echt vele dingen, die kanten klaar. Daar heb je ook M3 formaat, hè. Kijk, M5 of 6 of 7, dat kan je gewoon prima printen. Dat is echt, ja, dat werkt veilig. Maar als je ik gebruik voor M2 en M3, dan, ja, dan dat is wel lastiger.
Meer, ik had wel een grappig doosje gevonden voor de CWT network, nog lang niet los.
Ja.
Alleen dat doosje is dus gewoon, er zat niet genoeg ventilatie in, dus het werd gewoon te warm.
Ja, dus dan wil je een paar sluisjes eruit halen.
Maar dat ontwerp is natuurlijk alleen STL van. Dus,
ja.
Nou, hoe hard kan het niet?
STL is niet opnieuw.
STL STL kan je nooit wel niks mee.
Nee.
Nee, wij plaatsen niet deze maken of iets dergelijks.
Ja, STL kan je wel aanmoedigen, dan kan je met een
Ik kan het volgens mij wel.
Ja.
Dacht ik.
Nou ja, je kan het wel importeren, maar je kan er nog niks mee doen.
Oh.
Van de software af.
Maar als je gewoon een STL wil modificeren, is Meshmasher het meest handige programma.
Ja, dat denk ik gewoon ook zo.
In Meshmasher kan je heel makkelijk ook een extrude uithalen en dan, of het vergroten of stretchen. Of,
Dan moet je het gewoon kanalen programma zetten.
maar dan ga je dus echt in het klassieke 3D-programma tekenen.
So what is this valve function actually doing?
So the whole, so if I, for instance, I would roll the 4 cylinders of this chair, and I put a hole comment around it, it makes a shape of the outer diameter of wherever I could place these objects. So the triangle that you show, that I show you.
But it will leave some steps, right?
So if I, for instance, have this sphere, I don't know, and I'll put somewhere else. I'll put I don't know a cube. Then. So I have now a sphere and a cube, right?
Yes.
If I now put a hole command around this, you will see it will make a shape of that whole thing. It's like putting a wrapping paper around something, around all the edges that you have drawn.
Shrink foil.
Yeah, and it's a shrink foil concept. And as you can see, if you would see this object, you couldn't imagine that this is just two shapes. Because this looks quite a complex object. It's just two shapes with a hole command around it. So that's what, and you can use hole for to make much more complex shapes is what you do with the hole command. You draw the basic shapes, put a hole around it, and you have your main thing. But the common thing where you would use a hole command is that if you would, for instance, place that same circle, for instance, in different spots. So yeah, I prefer to put 4 of these circles in the 4 corners. So I have four circles, right? That I have now placed. Again, if I put a hole around this, I get a very nice rounded corner.
You can use Minkowski to do that.
Sorry?
Minkowski, you know that?
But Minkowski,
It's nice. I know.
it can do very powerful things, but it's very complex to understand. And its behavior is very unpredictable.
And it's slow.
And it is slow. So, unless you go really you can use tons of libraries. But in the beginning, just learn to make something of basic shape. Because if you understand that well, then you can take any other thing. But it's really not that difficult to do yourself. Especially if I would make this into a function myself. If I would make a new function called cube with corners and use the variable, it's a super simple function to make, as you can see. It's not that difficult.
Yeah.
And the main thing is, I think one thing if you never 3D print, you don't think, but you have to really learn, when you design for 3D printing, print a lot, because you also don't know what the difficulties are of 3D printing. Because whatever I design, I also immediately think, can I print this without support, strongly, and those kinds of things. So you have to really combine the knowledge of design with the limitations of 3D printing to start making very good, easy, usable things. So at everything I look is also, am I going to run into issues with my 3D printer, yes or no? But yeah, you can use the more extensive libraries. This is you have to do something for it. This is just built in, it's very simple to use. And as you see, it's a powerful command. Your imagination is a limitation.
Is there a function for polygons?
Yes, there is. So that's the only shape that I did not define because in the beginning it's more complex for people to learn. But yeah, there is this concept that says where you can draw spaces. So where you can literally specify the spaces, the locations of the corners, and it will make you that shape, whatever it is. So here you can make insanely complex shapes by just specifying all the corners, the faces to do. But to learn that in that way in the beginning is quite challenging. Because this shape, while it is made with all these polygons, I can also make it just with basic shapes. Because if I wanted to have sloped corners, I can just do a difference with a rotated cube to get the same effect. So you'll find there's many ways that lead to Rome. Same thing here. So in the beginning, I would highly recommend you just stick with the basic shapes and be creative with it. Using rotate, using the whole command, using the diff, you can get very far with it. But at least it makes it still very understandable for you to read your own code. Because if you see this in code, yeah, no freaking clue what. I have to render it to understand it. But it's much harder for me to make it something that I can easily later on modify. But it's possible. So yeah. Did you make something?
I was trying to make a hexagon, and that proved to be fairly difficult. But
A hexagon.
a hexagon.
So a hexagon is 6 squares with a rotation in a loop
That's one way.
with a whole command.
I did it with cylinders, 6 cylinders in the corner. And
So, but then you have a hexagon with rounded edges.
Yes,
Yeah.
but I can make those edges very tiny
Of
if I
course.
want to. So.
And this is a programming language, so you can use a for command, right? A loop command. So you don't have to draw it 6 times. So you can also therefore make it modular. If you want an octagon,
I already. Yep, it just made an octagon.
there you go. See, that's the power. If you know a little bit how to program, you can then very quickly make it.
I already made it customizable in that way. But
And that's the only thing I think a lot of people in the beginning also, I do this a lot with children, the rotate command, to know which axis to rotate to get the right effect is often a trial and error. Not many people get the rotate typically easily understood.
There's actually a polygon command.
Yeah.
Then you can make a circle with number of sides. With the grid, the FM function.
Yeah, but the FN function goes over your whole program.
Yeah, you can also do it in one line.
Of course, because it's a semicolon. So you take a semicolon off and just specifies it for one shape.
So if you put it in 4, you have
Yeah, so
square.
if I put a cylinder radius. And I make this less resolution. So you say I can do a string fn.
Yeah, you can put it in a cylinder line as well.
No, actually it doesn't take this. So, because now I get it, but this fn, okay, let me see if that works and if I can later on re-specify the fn. So if I make this...
you should put it in cylinder command.
You just can put it in
in the cylinder command, okay.
According to the cheat sheet.
Called fn?
Just dollar FN is 5 or something.
You can also
And then I can still have my fn to be high for my whole thing, I guess.
Yeah.
And it will stay that shape. Yeah, there you go.
You can also override the FN just in a module and it will not go out.
Yeah, that's true. If you make module, then it's also within just that module. So that's an even easier way to make a hexagon. There we go. We have a hexagon.
Een cilinder van 6 kanten.
Ja, that's a hexagon.
Geen cilinder meer, maar.
Well, the higher the resolution, the more it becomes a cylinder. Octagon, we could do a dodecagon is it called?
It's 12.
My child learned all these names. The dodecagon, or I don't even know. Yeah, that main cheat sheet is very useful for OpenSCAD. That's pretty much everything on it that you want. Be creative with it. I already made one batch. So you can also work with colors, by the way, in OpenSCAD. If you want to like make different parts and you want to make them different with colors, so you can put color code before each thing you draw, so you can actually see the difference between them. Let me give you one tip, by the way, while you're all hacking away. Something that's actually very useful when you start doing these complex commands. So imagine I am doing, I don't know, a cube of 20. And I want to do a cylinder of radius is 10 and height is 5. And so this will be a common scenario. You do a difference around this. You render it and you're like, hold on, where the fuck is my cylinder? I don't see my cylinder. Where is it? And maybe you're misplacing it and that kind of stuff. So in OpenSCAD, when you write an exclamation mark in front of something, it will only render that line. And you can do 2 lines with just the exclamation mark. So now if I re-render it, not on the cube but on the cylinder, I see where my cylinder is. So while it is in a difference command, well, therefore I will not see it. So imagine I place this in the middle of an object and I don't see it. I don't know if I'm placing it correctly. By putting an exclamation mark in front of it, it just isolates that part of the code and it will only run that part of the code. And especially in a long program, instead of remarking everything out and all that kind of stuff, it's sometimes very useful just to put an exclamation mark on 2 lines that you're struggling with. And then you just see that element, so you can see what you're doing wrong. So that's a nice trick to use within OpenSCAD.
You also put it before the curly braces, the exclamation mark?
You can put it on any line. So I think if I would do it on this line, I don't think it will. Well, yeah, I think it's not doing just the whole difference thing.
Okay.
But you can also do it on just 2 lines. So now it will still also do both.
Oh, okay.
So you can do it on as many lines as you want. But typically you're struggling with one item, and you're like, you can't see it in the overall thing, and by isolating it, you know you're completely misplacing it or something like that. And especially if you do a difference, you draw one object here, and you do a difference with an object that in space stands here, then you don't see anything, because it's a difference. This one will be just not there, and then you're like, why is it not doing it? And by isolating it, you can see that you're placing it in the wrong spot.
But it's not a negation operator, because the function don't return anything, you only generate.
No, yeah, it doesn't return anything. There is, as you can see, there is a console window in OpenSCAD, so if you want to do debug messages and that kind of stuff, you can do printing and that kind of stuff. I don't really know. Not sure what you want to use that for. I'll show you some stuff. I've made to mount a Raspberry Pi. You talk about quick fit and a press fit. So this is a mount to mount a Raspberry Pi to a pole. So I make 3D scanners, so I have 120 Raspberry Pis mounted to radiator pipes. My frames for constructing radiator pipes from the plumber. So you can very specify your pole diameter. So this is, again, the left part you have to rotate 180 degrees, but from a printing is how it prints, so it goes to the other side. So it's foldable around the pole with an M3 screw. And in here fits literally a Raspberry Pi on the two holes on the bottom of it, and it's press fit. So these bulbs go in the actual hole, so it literally doesn't move. And these slide, of course, over the board. This is a super snug fit for a Raspberry.
Why you have the small ball of the bulb? Do they fit in?
This one?
Yeah.
Yeah, that goes in the holes of the so that
So it won't slide out.
so it will not slide up and down
Okay.
on there. And this is again when I design stuff, I really because I have per scanner, I have to make 120 of these things. I really
What kind of scanner you have?
I make 3D scanners.
Oh, 3D scanner. Okay.
Yeah, so this is a Raspberry Pi setup, 120 Raspberry Pis with cameras. They said these are just radiator poles, or you can buy proper aluminum poles, whatever. And they have a mount for the Raspberry. And I don't make full cases, because for me to print full case size 120 times is fucking, I don't know, that's more than a month printing time. So I really optimize for as small as possible printing. And this fits and mounts the Raspberry super strong against the pole very much. And this is my new design, because normal was sliding over the poles. But I found that if you want to fix one in the middle, you have to slide everything to keep it tight.
Or even a tie wrap.
Yeah, or tie. Well, yeah, I like to use screws. So
You can make a complete plastic hinge with
yeah, you could. I thought about it again.
Okay.
For me, buying a screw
Okay.
is cheaper and easier than printing the hinge, having the risk of the hinge
Ah,
plastic break faster. For me, print time is. I prefer to spend €3 cents on a screw than have an hour longer printing time.
Okay.
Not if it's one object, not of course, but if you have to print hundreds of these, it's every 10 minutes you save is.
I'll put it very close together so the time to print of the movie.
Yeah, I also that's why I already normally put it in your slicing software together, but sometimes you really have a chance to get it really nice and tight.
Okay.
And the tighter I put it here, the less you have stringing and all that kind of stuff. So I typically already in OpenSCAD design how I put it together, because I can do that much more accurate than when I put it into my slicer. So, and the nice thing, my printer, if you see my printer, I use a BCN, it has two heads. So I can print this 2 times at the same time. So it prints 2 objects at the same time.
Right.
Because it literally separates the bed into halves. So as long as this fits on one half of the bed, and which it does, I can print it. And it actually prints 4 in a row. So I can print 8 things, and it's 12-hour print. So twice a day I just take a plate in and put the plate out. And
How do you connect all the Raspberry Pis? Because 120 Raspberry Pis in one setup?
sorry, yeah, how do I do it?
How do you electronically wire everything up then?
The Raspberry Pi has an Ethernet card in it.
Yeah, okay.
Standard network.
But they need 120 Ethernet ports to.
That is correct.
Okay, there's a lot of cabling.
No. So my current design is it's mobile poles. So there's a switch, an 8-port switch at each pole at the bottom.
Okay.
So that's where the Raspberry Pis at each pole go into, and then there's one cable going out of each pole into a central switch.
Yeah.
And I buy these switches. They're just PCB switches, so no casing, no nothing. Because I can also then much easier inject them in my own design from a mounting perspective. I get them from China. They're €10 each. They're gigabit switches.
Okay. And how do you identify then the Raspberry Pis which are connected to this?
So I made software. So I completely made software to do all of that. So it's actually not that difficult. I use UDP broadcasting to send out, because the key thing is the 120 camera need to make a photo at exactly the same time. And I mean exactly the same time.
Okay.
Because I actually make 2 photos. I make one. So if you look at the scanner, There are computer projectors around it as well, because so I use photogrammetry. With any camera, your phone, whatever, you can 3D scan stuff. I don't know if you know, but you can. Anything that does not move, that's the key thing. You take hundreds of photos around it. You have photogrammetry software. You put it up, and you get a super perfect 3D model. I can scan this whole space very easily. People there, on the other hand, they move, of course. So that's why you need multiple camera setup to easily do it. But photogrammetry is based on texture. So 3 cameras need to be able to identify a unique spot that they know it's the same unique spot. And because they see it from 3 different angles, they can triangulate and know where it sits in space. Now, if you would be wearing a white t-shirt, or a pure black t-shirt, something like that, and I make a photo of it, just white or black, and if I would take hundreds of photos of this wall, I wouldn't be able to 3D scan it. So what I do is my computer projectors, I make 2 photos very quickly in a row, 17 milliseconds between. So it first makes a normal photo, and then the computer projectors turn on, and they project, I don't know if you can see it on the left, random noise. No, not a grid, random noise. There's a grid in there as well, but this is mainly random noise. But that gives each photo, no matter if it has texture or not, the texture so it can find the 3D spots. But this has to happen extremely accurate, because again, because we still use the right photo for the actual color information, right? Because the end result, I don't want to have people with the noise on it. But the difference between those 2 photos needs to be very short, because else you have movement of the person. So that's why the timing has to be extremely accurate. That's actually one of the biggest things, difficult things to do.
Microsecond level or?
Yeah, this is microsecond level, yeah. Because you have to deal with it. So the time between the 2 photos is 17 milliseconds. But in that meantime, you need to make the projector project. And a projector, it works, it doesn't instantly project an image, it works it scans line per line. So you have to get that extremely well now done. And what I also do is on the projection image, because the projectors are the most powerful I can get, but they're not still super powerful, is I dim the lights about 50%, so that the projection is also better visible. And all that happens in 70 milliseconds accurately. So that's a lot of it. But I use UV broadcasting for that, and then everything else on each Raspberry is an Apache web server running that serves up the JPEG images that are made. And I have Windows software that just pulls that out of the Raspberries, multi-threaded. Also, the other Raspberries are just 100 megabit. The networking, the physical networking is gigabit. And my software multi-threads at least 10 Raspberries at the same time. So I pull full gigabit bandwidth. If you imagine a single scan is 800 megabytes.
Yeah, that's pretty interesting bandwidth. Yeah.
So 3 times taking a scan is
takes a few seconds to train it.
It goes quick in data, I can tell you. And especially, this is still 5, but there's an 8 megapixel camera for Raspberry available in high. And there's new cameras available, not from Raspberry, but they do work on a Raspberry, that are 13 or 60 megapixels. So I'm testing out with the 30 megapixel. So the data sets are becoming larger and larger.
But how many frames can you put in DRAM after the Raspberry Pi? Because
because it's per Raspberry, right? So the Raspberry has, even the old ones have 512 meg RAM. If I need 2 images at 5 megapixel or 8 megapixel image, so it's fine. Video will be a different issue, but the images is so yeah, it stores, it makes photos in memory, and after everything is done, it saves it to the SD card. So that again, there's no syncing issues.
And using the internal camera interface of the Raspberry Pi and then having the camera connected to.
Yeah, I use the official for the 5 and 8 megapixels I am. For the 30 megapixels a different driver, but it is still it's through the MIDI bus. It's not through USB or something. Okay. USB is super slow, and it's completely not accurate from a timing perspective.
Yeah, because there's a completely different clock domain.
There are no high resolution USB webcams anyway, not in the resolution I'm talking about. So USB cameras are not allowed.
And there's a parallel camera interface of Raspberry Pi which is used by
that you have multiple cameras. Yeah, but they cannot be used at the same time. They can switch.
Oh yeah, it's only 1 camera.
But even if you have 4 cameras, I cannot take. I need on a millisecond level need to be able to take a photo at the same time. And with those boards, it switches between the cameras, and it can do it relatively quickly, but not quickly enough for me. So that's why I have to really have 1 Raspberry per camera.
And then also the settings of the camera itself, because
it's all controlled through the software.
Oh, it's all centrally here.
Yeah, it's all completely. You never have to touch the reservoir. Never. And that's for a stupid user page, right? It's a Windows user page. They just set the ISO, which will update every day. But it works well. It's a nice use case of a Raspberry Pi. And the models, so this is me. I don't know if you can see it. And this is with just with the 5 megapixel camera. If you see the results that I now made with the 30 megapixel camera.
This is with 125 pictures of.
This is made out. This is still without the cover, so this is made out of the projection set. So with 100, I think this is actually an old. This is a quite old scale. This was made with 95.
Okay. And the post-processing that takes off this 800 megabytes of data. That's.
So actually, in the past, they always did this with SLR setups. So this technology has been used for a long time. Of course, it's 100 Nikon cameras or 100 Canon cameras plus all the connectivity is insane expensive. But it's also not realistically practical possible because trusting a scan with the 24 megapixel camera of those cameras, it takes and I have a serious beefy computer for this. It would take 8 to 12 hours for a single model. So
you can parallelize it using OpenSCAD or something like that?
it's massively GPU optimized, massively on your CPU. It's not even possible pretty much to render. It's already so with extreme GPU cards, it takes them 8 to 12 hours.
Okay.
So that's and because we use relatively low things for us, a model, a raw model to produce is about 10-15 minutes on a 24 inch, which is okay. Still relatively slow, but it's okay. And then you have to manually clean it. So that's good enough for printing.
You 3D print?
Yeah, in full color. So this gets printed on a 660 3D systems. It gets printed in. So this is me 3D printed. Both.
Oh, wow.
And this is a comparison. So the left one is scanned using a Nikon 100 Canon Nikon SLR, so a set that costs 150,000 euros. And the right is scanned with a set that costs 10,000 euros.
And just for my own curiosity, is this system one? Is it calibrated beforehand?
No, you don't need to.
And what is the actual resolution that you got, accuracy you get out of it?
Yeah, so there's different resolution accuracy. So there's no calibration because on every single scan it figures out where the cameras are. So on every single so if you walk in my scanner right now, they're just radiated pipes. They're very far from being solid. And you touch any of my cameras, you do not break anything. Because on every single scan, the software will calculate what the position of the cameras are and where they are. So there's no calibration needed up front in any form or shape. Now by default when you scan, it doesn't know anything about real values. So it doesn't know what a meter is or anything like that. So in most photogrammetry software, I don't know if you can see this. So I have in my scanner, I have markers that the software can recognize. These are like QR codes, and they are on a specified distance. So within that software, I can then specify the accurate distance between that, and that will actually calibrate the actual scan in real sizes. And how accurate is it? It is sub-millimeter accurate.
And this is the accuracy that you get if you really take a tape
Yes.
measure to it everywhere in the frame. Because I'm wondering if this technology would also help you if you are making smaller scans of things like prosthetic tubes, which need to be really accurate.
Yeah. So I actually have some of my customers are doctors that are making. So there's like a company that started out of the TU Delft. They make braces for people with arthritis. They use my scanner.
Is it
The miniaturized version of it.
I would say that's just a tube with a smaller.
Literally a tube that you stick your hand in.
And how many cameras would that have? Also 100 or just fewer of them?
No, fewer. One thing you still need always, no matter how big the circle is, you need relatively always, because the angle of degree, no matter if it's big or small, because you need overlap.
Yeah.
So you always need about at least 18 spots going round. So at least it's 18 cameras, and then I think they have 3. So I think they have 3 rows of cameras with 18.
But for instance, the space between your fingers will be very difficult.
So that depends on how more. So the more cameras you place, the less camera occlusion you have. But they're getting. So they from a student project, they have a full company now running worldwide that they professionally make these braces for people successfully, and it's very accurate. And it's the patients are extremely happy because normally they used to do it cast, which is itchy and not flexible or anything. And now they 3D print out of SLA, a relatively flexible SLA material that they 3D print that helps skin safety and all that kind of shit. And it's supposedly for people with arthritis, it's a joy to wear.
And have you ever really quantified the absolute accuracy? Because I'm also thinking for engineering.
Yeah, so we have, because I've done a lot of, so I have a lot of customers using this for all kinds of reasons, not just for the figurine, for that, because for that accuracy is completely not relevant.
Yeah.
But I have people from the clothing industry that uses this to do made to measure clothing, that kind of stuff. I have doctors using it for all kinds of research, for skulls and for prosthetics for limbs and all those kinds of things. Now the only thing that really decides the accuracy is not so. Photogrammetry is an extremely accurate method. If you compare to like an Artex scanner, which is a very expensive device, because the device moves, it always will give some correct errors because of the motion. This is instant, solid, it is therefore much more accurate. But, and that's the key but, it is dependent on the texture of the amount of unique spots it can identify. So again, if you would do photogrammetry on, like especially we scan a lot of children, if you take a girl and you would scan her hand nakedly, right, no clothing, a girl's skin, unlike my skin, is super smooth. So you would have a hard time finding unique spots in it to get a high resolution model out of it. By using the projection method, you completely then fix that problem. And they don't, because they use projection, they don't give a shit, they don't take 2 photos, because they don't need the color information. Right? So they just literally take only the model with the projection. And you get extremely, so as long as you make sure that there is enough texture for the software to recognize, photogrammetry works extremely. But like your glasses, I cannot scan with photogrammetry.
The reason I'm asking it is for engineering. Sometimes a customer comes with a product and goes, I need this product automated, and there's nothing, there's no drawings, there's no nothing. And for something like that, it would be really handy to have.
Yeah, but as I said, the material of the product is the biggest problem. So if someone would walk in with something made out of fabric, you can, with your iPhone, you would be very accurately be able to scan.
Yeah, but you say, you constantly say very accurately, but is there a known tolerance to, not just, well, it depends on the texture, is there a known limit, a tolerance of plus or minus this much, which to which this does? Because if you're making something prosthetic, it doesn't matter that it's 0.5 millimeter off, but in engineering, if you really need to figure something out, you need to know, is this accurate, plus or minus this many millimeters, and if you can't give that off, then it becomes kind of useless.
The thing is, because with photogrammetry, it is not it's not a fixed deviation, because it would have to do what cameras are you using? You can if you want, because each camera has its own deviation, right? Especially the corners and that kind of stuff. If you want to put the effort in for each camera, you can make a profile to do the correction of that deviation for just the image it's taken, and that will increase your accuracy. But you will find that for product scanning, photogrammetry typically still is very challenging, because most products have smooth surfaces.
Yes.
And that's where the problems comes with photogrammetry. That if you have a smooth surface, it's not scannable. So then you will more take an Artec who works with like a Kinect camera with infrared dots. It projects infrared dots on the surface and therefore detect it. Even that technology has sometimes challenges with it. So if you want to have something that's really glossy, then the only accurate method to scan is those arms that know exactly where its position is, and then by mainly doing all the touch points. So per object, there's many different methods of scanning. you have to figure out what the best scanning method is. But typically for product scanning, photogrammetry is not the most ideal way because of the services.
Sometimes you spray it with some powder.
Yeah,
or
but
paint.
some things you can spray.
Sometimes.
Like if it's a prototype, you typically don't give a shit if you spray. But like I have customers that scan for museums. Can I spray? No.
It's called good bad Bible.
So for those actually we do use photogrammetry, but we don't use a setup with the projectors because especially the white sculptures with projection on that works extremely well because of course white works really well with projection.
I also on OpenSCAD have a problem where it doesn't do a difference. I can't really
Does it do a difference? Then probably the thing you're differencing is outside of the object.
I see two objects inside each other. So.
This is the rendering of F5. Hit F6. Because when it is exact in the F5 mode, you get this artifact.
I need to go down.
Yeah, you point.
I do need to go down. Okay.
When then something is on the exact layer, you get that strange artifact on the F5.
Okay. Yeah.
This is now where you take whatever you difference, you put an exclamation mark in front of it. You can see if you're doing it.
So now I'm doing what I want to do.
Anyone already making something cool?
Try
A submarine. That is cool.
Not a real one.
That looks already good in shape. You need your submarine. The only thing is, keep in
I
mind.
love you for something, but the problem is the entire society you're not actually as smart as these electrons. What you really want are the Swedish ones with the Sterling engines. Because they use liquid oxygen and diesel, and how fucking cool is that?
Alright.
Liquid.
If you do want to, well, there's good nuclear technology nowadays available as well, right?
It's the instrument.
If you want to print it, just think about from a printing aspect. Because if the bottom is completely round,
Yeah.
you'll have a. Now, of course, you could try to print this up like this in the direction like this, because you do have a thin, so that might work.
This was that would be a pain to print.
Why? No. You would print it with support, but it's a different thing if it looks so like a submarine. You probably would print it from it looks pretty. So then the moment you do support, so then you can print anything, so it just becomes ugly. Because you move the support, so if it's functional, you print it with support, and you remove it might be pretty. Like if you want to make something pretty, you have to think about pretty. Ideally, you want to put something, but all of this can be printed without support. Just keep in mind the overhang on a 3D printer, if you have the temperature right, it can be more than 45 degrees. So yeah, well, not even cool, you should maybe not print it with a too high temperature, so that it just instantly, or it doesn't really get too fluidly out. My printer, I think easily in 60 degrees. So something like this is not even 60 degrees at all. Your problem with this is finding something, you probably on the test submerge it a little bit of flat, so that it's strong enough to stay on it.
I wonder if you printed it at that angle, so that you have 3 points of contact for the base.
Yeah.
So you have those, that, and that as the base.
Yeah, but this, no, but only this hits the base, right? Because
No,
those,
is it all three?
oh, those.
You see what I mean?
Yeah.
So,
Yeah, of course, in the printer, what you can set is you can print a skirt around it.
oh yeah.
And it will be stuck to the actual, again, you knife to just cut it off. Yeah, and I use on my printer something called 3D lock. It's like a hairspray kind of thing, and it makes everything stick extremely well. So even the tiniest surface will stick while it is hot,
Yeah.
extremely well. So you can have relatively small surface objects, and then still on top of that, you'll bring something very big. It also depends on the type of printer. So on my printer, the bed just goes down. But like on a Prusa printer, two axes are in the frame, but one axis is the bed itself.
So those are the ones I've done.
So the taller you print with those things, and the less certain, because you literally physically moving the object. So you might get a wobble, but in my case you never get a wobble because the bed only goes down. So the axes are only the head has all the axes. And this also depends a little bit on the type.
What my lab had was like a
Ja, want dit heb ik